So over here in this image, we can see that there are two shapes. One is a square. An object is placed at some point in a plane. Okay, so it is placed at this point. So let's understand it through the images over here. Hello everyone, I welcome you all to the first session of Unit 2. Yes, we have completed our Unit 1 successfully. And over here, Unit 2 is all about understanding computer graphics in a more descriptive way or in a more depth way. So that is all about computer graphics and fundamentals. Over here, my name is Deepa Kutnikar. I'm working as an assistant professor in the Department of Computer Science, Vidhyaashram, Temple of Excellence, Mysuru. So let's see what is the agenda of today's session. In today's session, we will be learning and understanding the coordinate as well as geometric transformations. Up next, we do learn and understand the translation, rotation and scaling of the images. Like what is the theoretical aspect behind these things. Then we do discuss the homogeneous coordinates by using the matrix representation. Then later, we also do discuss the composite transformations which are required where the geometric transformations can't be applied. So we do study this composite transformations. Up next, we do study the pivot point representations, that is general pivot point rotation, then the general fixed point scaling as well as sharing, reflection. We do understand the basic reflection. Along with it, we also study the reflection about an arbitrary line. So this is the agenda of today's session. So let's go with basic introduction to 2D transformations. So we have heard the 3D transformations, but in order to go with that 3D transformation, first we have to initially understand the 2D transformation and why it is called as transformation, because there will be a movement of an object or a graphical image from one point to another. So that's why it is considered as a transformation. Now, while transferring this, we also do some changes that make the image represent in a more qualified manner. So a 2D transformation is particularly utilized to modify the position, orientation, size, as well as shape of a graphical object. So over here in this image, we can see that there are two shapes. One is a square and one more is a diamond shape, correct? So now there is a transformation happening, and that transformation is happening in a plane coordinate and it is considered as a 2D coordinate, and in turn we call it as a 2D transformation. Now let's see what are the key points related to this 2D coordinates. So these transformations are particularly used in various animations or in CAD drawings as well as in games and in GUI designs. So that's the basic thing what we do use or utilize in our animations. Up next, the objects are completely represented using the coordinate points. Now, what about the transformations? Yes, we know what is a basic concept of transformation, but how is it theoretically successful? It's calculated by using few mathematical formulas or mathematical concepts. That is the transformation all about. Now let's see the transformation between the 2D coordinates. Over here in this figure, we can observe there is a line joining which is completely represented in a XY Cartesian system. Now here x dash y position is being considered. Okay, so x dash y Cartesian position is been considered with x y naught at the orientation of a 0. Okay, so this is the initial image. Now we will be seeing how the transformation from this xy axis happens with respect to our x dash y dash coordinates. So let's move with our second image over here. So in this image, this is a continued image of our image 1. Over here, the translation is happening. So the translation of the origin from x dash y dash system to xy coordinate system is been considered. Thus, we can see the transformation from x dash y dash to a basic xy axis that's between our line drawing. So that's the image which is a complete continuation of our image 1. So this is how the translation happens with respect to a 2D coordinate systems. All right, now we have seen the translation of a line joining, that's from x dash y dash to x and y coordinate systems, correct? Now it's time to understand like what is a coordinate, what is geometric transformation, and what is a basic transformation. Let's start understanding with the basic concept of coordinates. So the coordinates, it just represents the positions of a object in that plane. Okay, so over here we can see that this is my xy plane, and in this xy plane if I place any of the object and that object's position in a plane is considered as a coordinate. All right, so that's the coordinate. Up next, what is geometric transformation? The geometric transformation, this as the name itself says, that is responsible for changing the geometry or the object's location in a plane. All right, so that is a geometric transformation. Now let's see what is our basic transformations. The basic transformations include the small changes in the images like scaling, rotation, translations, etc. So these are considered as basic transformations. All right, let's move forward. Up next, let's continue our topic, that is coordinate and geometric transformations. We know that geometric transformation in the sense changing the position of a geometric object, correct? So that's inside the plane. Now let's see like how these positions are changed, starting with translation. Translation in the sense a object is placed at some point in a plane. Okay, so it is placed at this point, and after applying the geometric transformation, or we can say that basic transformation, we can note that our position of the object has been changed or it has been updated. So from here it is shifted to this coordinate. So that is a translation. And next, the rotation operation. So rotation, we know that the basic rotation happens. Even we do the same thing for our photos in our mobile phones, correct? So if a photo is in a landscape, then we do rotate it to portrait, or if a image is in portrait, if an image is clicked in a portrait mode, it is been rotated to a landscape mode. Why? Because we believe that by shifting the position of the image, we can have a look of that nice image precisely, correct? So same thing will be followed here. Rotation in the sense, here in the plane the object is placed here, and after rotation the image or the object will be tilted to some extent, and it is considered as a rotation. Next is the scaling. Scaling in the sense, if a object is so big and it can't be fitted or fixed in a frame, then we can go with a scaling option through which we can minimize the pixel amount of that image, and that object can be easily seen in that frame as a successful conversion of the scaling effect. So these are the basic transformation as well as the geometric transformation that can be considered. Over here we can also see that not only that shape but various shapes can be transformed. The complete geometric image, that's like here it was a square, and it when it is shifted to some other axis or some other coordinate, it won't become a rectangle or a triangle, it will remain as a square itself. Okay, so that's the geometric transformation. Just the position will be shifted and the complete image geometry will be maintained as it is. So that is all about a geometric transformation. Now let's understand next basic topic, that is translation. So in basic words, translation means moving something, moving from one position to another, correct? So it's the same thing when it comes to the translation in computer graphics. Translation in the sense moving an object from one position to another. It's the same thing. So that is all about a simple definition of a translation. Now let's see what is the formula that can be utilized for this. So with respect to x dash, it can be written as x plus tx. What is tx? Translation with respect to x-axis. What is the extent of translation? So that is noted in a form of tx. Next, y dash. equals y plus tx. So even here tx remains the same thing. Next, let's see the representation in the matrix form. So x dash y dash 1. Alright. Now, so over here in this matrix, we know that our tx and ty positions has to be updated with the translations. And what about the rest? The principal diagonal elements will be completely considered as a unit value. Then it will be multiplied by x, y and a simple one. Now over here we have considered a 2D translation of a simple object. On that xy plane, a object is placed at the coordinate of 4, 5 and 7, 5. Now for this, if we go to apply the transformation formula, or if we apply this formula, that is p dash equals p plus t, that is p is the basic p values or the position values what we consider, and the transformation value like where we are supposed to transform. So if we provide that value, so let's see the matrix form for that. X dash y dash equals x y, yes it is there, plus dx and dy. So through this, we will be getting a new value of xy, that is a complete transmitted value of the complete object, which results in starting point is 7, 1 and the ending point is 10, 1. So this is a complete basic translation. Now let's see the next thing or the next topic, that is a rotation. So this rotation, we have a good idea of what it is. The object will be turned by keeping some reference point, correct? Yes, that's the same thing over here. Rotation turns an object about a reference point. Now with respect to that, what is the matrix representation? Yes, it is like cos theta minus sin theta followed by sin theta and cos theta. This gives a complete rotation matrix. And we have an example, that is rotation of a triangle by 45 degree. Let's see how is it done here. We have a complete 2D plane. So initially we will be having our complete p, that is x dash y dash. So that's the initial object, and that object is scaled and rotated for a 45 degree, correct? So how is it done? By the matrix formula, as well as we can directly consider x equals r into cos phi and y equals r into sin phi. By applying this, we get our x dash y dash coordinate object values to be rotated with the angle of 45 degree. So this is with respect to rotation. Let's move next, and the next topic is scaling. All right. The scaling is utilized to either enlarge or reduce the size of an object. Now let's see what's the formula for scaling. There is x dash equals sx into x, and similarly y dash equals sy followed by y. Now what are the things that we can expect over here is we have a good xy coordinate, and in that coordinate the initial object was this, which is drawn in our dotted lines, and it is being scaled, or the size of that object is been reduced to a simple xy, that is the small xy. Okay, so this is with respect to scaling. All right, let's go with homogeneous coordinates. That's with respect to matrix representation. So now let's understand what is a homogeneous coordinate. It is used to represent all transformations using matrices only. The various advantages of this matrices are: the first advantage is it's easy for computation, as they only use the matrices, the computation becomes easier. Next, it supports the composite transformations and it is efficient in graphic systems. So these are the basic advantages. Now let's see how the matrix are considered. For example, the homogeneous coordinates for xy plane is considered as xh, yh, h. Now, what is this x? Yes, the x is formed by considering the homogeneous coordinate of x-axis divided by the h coordinate. Up next, with respect to y, it's the same thing. The homogeneous coordinate of y whole divided by the value parameter of h. So this is a x and y value. Now next, the matrix representation, that's with respect to translation. So now see that x dash y dash will be our initial matrix, and with that we will be adding a 1 in order to make it as a 3 cross 3 matrix. Now the principal diagonal elements are all considered as 1, and the rest tx and ty, that is translation with respect to x and the translation with respect to y, are considered, and it has been multiplied with a x, y and a 1. So this is a matrix representation. All right, what to do if the basic transformation as well as the 2D transformation won't work? So we have to switch with more complex transformation, that is none other than a composite transformation. The multiple transformations can be combined into a single matrix. So very advantageous and most widely used type of transformation, transformation that's with respect to real-time graphic environment is a composite transformations. Example of it can be considered as a translation or scaling or even the rotation. Now let's see, the final matrix will form the S into R into T, that is our simple scaling into rotation into translation. Now the continuation, if we want it with respect to matrix format, then let's see how to consider it. That forms in a way of addition, that is scaling plus rotation, that is scaling plus rotation plus translation. So all put together we form a single matrix. So now let's see how is it possible. So P dash equals T into R into S, which will be equal to P of, we know the transformation matrix will be written as 1 0 Tx 0 1 Ty followed by 0 0 1. But the rotation matrix, so even this we have learned, that is cos theta minus sin theta cos theta, then followed by 0 0 0 0 and a 1 in order to fill that principal diagonal element. So that is R. Next, the scaling. Scaling matrix, it includes Sx, Sy and 1 along with the translation in Y. Why? Because the scaling making it bigger, making it smaller, all will include the y-axis, isn't it? So that's why only Ty is been considered, not Tx. And finally, all these are multiplied with x into y into 1. Next step, let's consider the transmission over here, the multiplication, and since it, after multiplicating these two, that is our translation matrix and the rotation matrix, we will be resulting with this final matrix, that is cos theta minus sin theta Tx, then sin theta cos theta Ty followed by 0 0 1. Okay, so this you have to do the multiplication, that is matrix multiplication. Here you won't get 0 because you have 1 into cos theta, you will be resulting with cos theta itself, then 0 into sin theta plus, again you have to do the process. So if you do that multiplication, you will be resulting with this matrix. If you have any doubt, you can check multiplying, you will be getting with this result. Up next, let's retain this third scaling matrix as it is and our x, y and 1 as it is. Up next, in order to do, up next, let's read the transformation. So over here, by seeing our first and next matrix, we can say that our cos theta minus sin theta cos theta again will be a rotation matrix, correct? So we have considered it as R dash, that's with bit changes, and Tx and Ty can be considered as a translation, correct? So we have written T. Then along with this 0 2 has been summed up with a 1 0, then followed by 1 is retained as it is. Similarly, with respect to this Sx as well, only the Sx and Sy are considered. So we can consider it as S dash and a 0 for this followed matrix, then 0 and 1 for our basic thing, that is in order to fill our principal diagonal. So we can say that by multiplication of these two things, we do get R into S dash followed by T 0 1 into x into y into 1. So this is the form of general purpose transformation matrix. So we have reduced all the various types of transformations into one single matrix. All right, let's move forward. The next topic is pivot point rotation. So how it works, let's see. Rotation can be performed about any arbitrary point, but here as we are considering pivot point, we have to consider it as arbitrary pivot point. Now let's see what are the steps included in this. The first step is translate pivot to origin. Okay, that's the first thing. Next, we can rotate the object, and the next step is to translate it back. So after rotation, if you want that translation, yes, you can do with it, or you can go with it. So now let's see this process by the use of figures. Initially, we will be having an object. So this is the object, and inside that object, a pivot point is fixed. In the sense, a point that's a reference point is fixed, and it can be considered as xr comma yr. Okay, that's the first thing. Next step is we have to take this pivot point towards the origin. So we are translating the object towards origin so that the pivot point is placed exactly at the origin point. So that's our next step. And after that, we can go with rotation. Okay, shifting the point is done, shifting of object is done, then we are rotating it. And finally, we will translate the object from this position to its previous initial position so that the pivot point is at its initial point itself, and we get a object that is rotated. So this is a process that is included in rotation of an object, that's with respect to pivot point. So whenever this question is asked, it's better to draw this simple diagram as we also get a continuity of the content. So let's move forward. The next thing is general fixed point scaling. So how this is done, let's see. The translation object is done so that the fixed point coincides with the coordinate origin. Up next, we can scale that object with respect to the coordinate point. And finally, we can use the inverse translation of our first step in order to return the object to its original position itself. So now let's see this flow with a basic figures. So this is the initial figure where we have an object on the coordinate as well as a point. So this can be considered as original position of an object and a fixed point. All right, let's move with the next image. Again, it's same as our previous pivot point. So over here we can see that the object is brought down towards origin so that the fixed point exactly coincides with the coordinate point, that is xy coordinate point. So that's our next step, and at that point we can do the scaling, that is enlarging the image or concising that image, whatever we want according to our requirement, we can do it. And up next, finally, we do the inverse translation in order to shift that object from the origin to its initial position back with a fixed point placed in its initial position. So this is a general fixed point scaling. All right, let's move forward. Okay, the next concept is shearing. Shearing in the sense there will be some distortion in that plane. So now let's see what is the definition of it. Shearing distorts an object by shifting coordinates completely in one direction. So we have different types also. We have X shearing. If there is shifting happening in X direction, we can call it as X shearing. And similarly, Y shearing is there if the distortion or shifting happening in Y format, then it can be considered as Y shearing. So we have a basic example. So this was our initial object that's with their XY coordinate values. And after shearing, so we have this shearing formula, that is P dash equals S HX into P. So the transmitted image can be called as X dash Y dash, correct? So for that, we are considering SHX, that is shearing value. followed by 1 at the principal diagonal elements, which will be multiplied by x and y, that is the previous values. So this will be resulting in this kind of distortion, that is completely shifting an object in that x plane itself. All right, let's go with the next topic. It is reflection. So reflection, we know that through reflection we can get a mirror image of the existing object, right? So let's understand it through the images over here. We have a original position of image here, and we are getting a reflected original object in our next plane, correct? So that is minus of x and minus of y plane. So this is reflection about x-axis. Now, if you want to see the reflection about y-axis, then you can see the original position of image in our negative xy axis, and we can get a reflected original image in our positive xy plane. So this is the reflection, or getting a mirror image of the original object. So we have different types in this. Initially, the first one is about reflection about x-axis, then reflection about y-axis. Also, we have third one, that is reflection at the origin. So these are the kinds of reflections that is available with respect to graphics environment. Okay, next let's see the reflection about an arbitrary line. So how is it possible? Let's understand over here. Any reflection can happen by keeping a line as a reference, and that is considered as an arbitrary line. Now, in order to do this, let's see the procedure that is followed. The first step is translating line to origin. Okay. Next, we will rotate the line to x-axis. Then we apply reflection about x-axis, and finally we do reverse transformation in order to get that object to the initial position. So now mathematically, let's see how is it done. We have x dash y dash, which is equal to 0b, in the sense a and b, but here as we are dealing only with the x-axis, the a will be considered as 0. Next we have r theta xr, r theta inverse. So that is with respect to the line or the image. If the image is there with a reflection angle, we can consider that reflection angle, followed by the original xy values, and which will be again summed up with the inverse transformation. So this is the expression. Now let's see a figure. So over here, this is original image, and through the reflection along the x-axis, we are getting the reflection of that image over here. Reflection of image over here. So we can observe reflection in any line can absolutely be got by following this process. So this was with respect to today's session. Thank you.